Everyone, my name is Sai. I'm a PhD student at the Human-Computer Interaction Institute at Carnegie Mellon University. Today I'll be talking about our project OptiStructures. Now, this project is joint work with collaborators from civil and environmental engineering. Now, before we begin going into the details, I would like to show you 20 seconds what we mean by OptiStructures. As you can see, these are structures that are typically passive but are responsive to human interaction. Now, if you look around us, human environments are surrounded by structural elements like walls, hallways, beams that are pervasive and are yet just mostly passive. So one key question we wanted to answer with this project was, how can we design structures to be interactive at room scale? In prior work, researchers have looked at fabrication and material-oriented approaches to bring large-scale interactivity. Living Wall project used paper-based electronics to bring large area interaction and displays at the surface. This technique, however, doesn't enable room-scale interaction. A more recent project, Wall++, looked at painting antennas on walls to track user activity and interaction at room scale. This project missed out on providing visual feedback to the users. Most recently, sprayable user interfaces this year brings interactivity to large-scale surfaces by spraying conductive materials. Again here, the interaction worked at the surface level, but at room scales further away from the structures, interaction possibilities were limited. So to summarize, providing visual feedback and room scale interactivity simultaneously was missing. Now that's exactly the idea behind OptiStructures. We wanted to use optical fibers to enable room scale interaction and provide visual feedback in structures. Now let's take a look at how it all works. Now if we have an optical fiber of any length, and we pass light on one end, then the light comes out on the other end. This is relatively simple. But how can we use optical fibers for sensing? Let's take an optical fiber and look at what happens. First, we shine a broad spectrum laser source through the fiber. Now this produces an optical pulse. Now this pulse moves along the fiber until it reaches a grating that's purposefully placed in the middle of the fiber. If you look closely at the grating, when the optical pulse passes through one end, then there are two things that happen here. First, a reflected signal comes through the same end through which it was passed, and the remaining transmitted signal is produced through the other end. Now, while all this is happening, if a vibration occurs, then the vibration causes a shift in the reflected signal and the transmitted signal. Now, the shifted reflected signal is carried all the way back to the source, where the detector can then detect the change in the vibration. Finally, the remaining transmitted signal can be carried further along the optical fiber and can be used for sensing activities at other locations along the fiber. So until now, we've looked at how optical fibers can be used for both sensing and displays. Now let's look at how optical fibers can be integrated into the structures. First, a mold is placed for casting a structure. Next, we use a custom-designed optical fiber extruder to programmatically place fibers. After placing the sensing and display fibers, materials are casted onto the mold. Now, after that, the casted structure can be retrofitted into existing walls or can be used as is. They can be used for both display, sensing, or both. Now, there are many applications with these type of structures. I'm going to show you a few examples to give you an idea. First, an interactive contact directory on the wall can be used to find out where a person is located. Second, we can proactively give safety alerts to people while they're doing any activity. Now, there are many more interesting examples and material experiments in the paper. In the interest of time, I invite you all to look into the paper for further details. To summarize, we introduced a method to create room-scale interactive structures for sensing and visual feedback. Now, we're really excited about taking this approach further. In the future, we aim to have the ability to sense activities in structures that are spanning large infrastructures and even to city scales. Now all of this is possible without needing any battery or maintenance. With that, I would like to end my talk here. I thank you for your attention, and I'm now open to questions.